Hey everyone, this is Ben Watts for Entagma. Today I'm going to show you how to create some really easy growth inside of Houdini. What we're going to do is create some start and end points, calculate the shortest path between those, and look at ways to manipulate the growth patterns that we get. Let's jump in and have a look. Okay, so let's get ourselves a geometry node. We'll put that down, jump inside and get rid of the file. And let's start with a font object. So I'll put down a font. And given this is an Entagma tutorial, let's put the letter N and just move it up so it sits on the ground plane a bit. Just a bit more. That looks good to me. Now we want to add a bit of thickness. So let's put down a poly extrude. And we want to make sure we check output back. We can add some vertex normals and just grab this distance and drag it out so we've got a bit of thickness. Very good. Okay, so after this, we're going to subdivide our geometry, not with a regular subdivide, we're going to use a divide node for this. And we're going to uncheck convex polygons and turn on bricker polygons. And just drag that down. And we need to enable our wireframe. So over the viewport here, just hold down Shift and press W so we can see our divisions. And just drag that down until we've got a decent number of subdivisions. Just have a look at it. And something like 0.04 should work. Okay, now what we want to do is make two groups. One will be the start group for our growth points and the end group. So we'll just do this manually. I'm going to put down a group node. And my groups are set up to use a $OS in the group name, and then I've right-clicked and made that the current default value. Just so every time I put down a group and I type in a name here, that actually becomes the group name. You just want to be careful. Sometimes when you change these names, you might need to bypass then unbypass just to make it refresh. So we've got a start group. We want to set that to points. And we will actually leave it at pattern. Let's just put 0.0 in there for now. We click that, we can see our 0.0 is right there on that front face. Let's Control-C, Control-V that to copy it. And let's just call this one end. And let's just change the group operation to range. And we'll say, let's group every second point in this mesh. And then you get this strange pattern that we see here. Okay, that will work. Then we want to put down the find shortest path node. So this is a node that does all the magic. And this node actually does a lot of stuff. If you have a look on the help card, there's a lot of cool things it can do. We're going to use it in a really simple way here, as you'll see, but it is worth looking into. So let's just select for start points, our start group, and for the end points, we'll get end, of course. And we want to change this mode under output paths to the third option down. And it's from any start to each end. As soon as we do that, we can see from our start point, we have a path calculated to each end point, okay? And it gives us this kind of cool shape. It's not that interesting, it's quite linear, but we'll see how we can easily modify this to make it more organic and interesting. And one thing to note here, what we get here is this thing called a cost attribute. It's just a point attribute, and it's a bit off the screen here, but it's basically just gives us a value, which is almost, you could think of it like a distance, I suppose, from the start point to the end point. And it's really useful in terms of remapping things like thickness of polylines or whatever we might want to sweep along our curves. Another cool thing that it does is allows us to select a group of edges to avoid. So this is obviously great if you want to account for obstacle objects and just have your path grow around those objects. We'll take a look at this feature a little bit later. So next up, we'll put down a carve node. Okay. And let's uncheck the first U, check on the second one. And we'll see, just like that, we've already got some growth happening. So as you can see, it only takes a few nodes to get up and running with this effect. Very simple and straightforward. All right. Let's just put down a null so we can get rid of those blue guides. So that's looking pretty good for a start. Let's just have a look at what else we can do to improve this. So what we might want to do is have a look at ways we can change our topology, since that's the thing that governs the way our paths grow. It's all based on the edges of our mesh. So let's have a look at that. So let's go back up to the top here, select the divide node and just move these guys up. And let's just drop a remesh in underneath the divide node. Okay, we'll enable that and let's just give it quite a bit of detail. We go back and let's go to our carve. And already you can see, quite a cool looking structure. Okay, so let's have a look at a couple of other things we can do to enhance this effect. Before I get started on this though, I'm just going to make sure I've got my carve animated because it gets a bit annoying dragging it manually all the time. So I'll just go to frame 1, set it to 0, hold down Alt and left click in the box here to set a keyframe, come out to frame 100 and set that to 1 and set a keyframe. So now I can just scrub. Makes life a bit easier. So one thing I do want to talk about with this is the idea of having this grow in a volume, which isn't really as easy as the usual method that we do with growth algorithms when we're using points and things like that. Well, not that I've found anyway. However, there is a hacky way that I figured out we could use for something like this, a singular letter, which is quite easy to work with. There may be other ways to do this, but bear in mind, because this effect uses the actual edges of the geometry, not the points, we need to look at this in a different light. By the way, if anyone has any better suggestions on how to do stuff like this, I'd love to know. But the hack I came up with in this case was to just go underneath our remesh. I'm going to put down a tetrahedralize node. And if you don't know what that does, basically it fills the object with polygons essentially, or primitives. So it doesn't have a hollow inside like a regular piece of geometry would. And you can see the effect is quite nice. We've got our growth going right through. It can get quite slow as well, so you've just got to watch out for that. But I just thought I'd show it because it is a neat little hack if you need to get this going in a volume, or the appearance of going inside a volume rather quickly. So we can scrub this and it still is relatively responsive. Looks good. One thing you'll note, we've just got a singular growth point here, but we can easily change that to make it look a bit more interesting. So just come up to start and let's just type in some random numbers like 500, 2500. We can see now we've got 3 growth points and it just makes the whole effect look a lot nicer. Another thing we can do is come down before our carve. Let's put down a smooth. And you'll see it goes quite hairy looking. And that's because, remember, we've got a ton of endpoints, but just a couple of start points. So we've got a lot of paths essentially overlapping. And this could be something that you find useful. However, if you do want to sort of, restrain that look a little bit, what we could do before the smooth is just fuse some of these paths together like this. And we get more of our original look back. So it's just another thing you could do. Of course, you could play with, different values on the smooth and you'll get much different results. These are all fun things to play with. So now we're going to take a look at how we can add an avoid group to make our edges grow around obstacle objects. So what we'll do is come up here and let's just put down any old piece of geometry. We'll go sphere. We'll just template that. And we'll make the uniform scale maybe 0.02. Well, 0.2 should be much better. Just move it up a bit in Y. Like that. And move it forward in Z. We'll take a chunk out of our existing edges here. Okay, then move these nodes down. So we've got a space under the end group. Put down another group node and let's just name it avoid, remembering that I have $OS up here in the group name, so it'll take on that name. I want to set this to points. We'll uncheck this enable box here, go to bounding, check enable, and we'll choose bounding object points only. Just note that I wouldn't normally use this mode, it's quite slow, but this is just a very quick example. Usually I'd turn my bounding object into a volume if I had to use it and do it like that, but there's no need in this case. We'll plug our sphere into the second input of the avoid group. Okay, and we'll select it and we can see we've got some points. The problem is that our find shortest path node needs a primitive group. Well, that's fine. We can go up to edit, convert, and change this from points to primitives and choose our $OS group. So now we have a nice primitive group to use. Go down to find shortest path node. On the end tab here called surface constraints, just check edges to avoid and select our avoid group. And there you can see we have a nice piece cut out. So if we go down to our null and scrub through, we can get a better angle on this. Might be hard to see, but it is indeed cut out. I'll just move it around a bit so we can get a better look at that. Okay, scrub this. And now we can see some of our edges making their way through. We'll untemplate. That's pretty cool. It's very simple and works quite well. So that's how you can just throw some objects in to create some obstacles for our paths. So now we're going to add a width attribute to our curves. So Mantra can render them natively, or we can visualize them with something like a polywire or a sweep. If you're going to use a sweep, you'd want to use the p-scale attribute instead, but either way, they'll work. But let's just put down a point VOP, and we're going to remap that cost attribute, which was generated by the find shortest path node, into a width in this case. So let's just call our VOP width, and we'll select that and jump inside. We need to bring in our cost attribute, so we'll use a bind. Then we want to remap that with a ramp parameter. So it spits out a 0 to 1 value. We'll make it spline ramp float catmull ROM for interpolation so it's smooth. And we'll export that as width. One thing I do want to do though is throw a multiplier in between here because we're going to be working with some pretty small numbers. So we'll chuck down a multiplier. We'll middle click and promote that parameter. Click on that little handle. Let's call this one width mult. Okay, default value can be 0.01 and we'll jump out. So we've got our ramp, we've got our width mult. Let's just bump this one up a bit like that. We'll put down a polywire. And I already know to turn down this maximum joint scale because it creates some really funky geometry. And let's just plug it in and see what happens. By default, it's got a hard-coded wire radius, which is 0.1, and that's massive in this case. So let's tell it to read our custom attribute called width. So I'll put down an @ symbol and type in width. That looks much better. Okay, so we can see we've got our thicker curves here and they're thinner here. we can probably adjust this curve a little bit to dial it in. Let's go back and have a look. Move it along a bit more. You can see it's working well. We've got some really thin stuff down here and thin pieces here. So again, this is determined by the start and end points and where they're located and everything like that. Okay, so now I'm just going to show you a little tip on how you would grow this stuff over, say it's the letter and it's sitting on the ground and you wanted it to cover the ground as well. So let's just go back up here. We'll zoom out a bit and we'll just turn off this tetrahedralize for a moment. And we'll just activate this remesh, turn on our wires, and let's just put down a grid. We'll make it a size of 1 and 1 and 20 rows, 20 columns, that's fine. I'll put a remesh under this grid as well. So we can see our grid here. Whoops, it's remeshed. You just get rid of the tetrahedralize for now. And let's just merge these guys together. Okay. So when we do that, we can look at our groups. We can see we've still got, our start points on the end. And now we've got points all over the ground. And we've still got our sphere. Let's just get rid of the avoid group as well. Turn that off. And let's have a look at our paths. So we've merged our geometry. However, there's not growth on both pieces, obviously. And that's just because they're not connected. So one little hack you can do here is under the merge, we can just add a fuse and we can just dial it up a little bit until the two pieces of geometry have at least, 1 or 2 points in common. And when we do that, come down to our null, we can see that our points will, start off where they were meant to, and then they'll propagate down onto the ground. And you can see the pattern's pretty interesting here. It might be a bit too smooth, so we could turn that off or just lower the amount of iterations. Remember too, if your paths ever get sort of ratty looking and jagged, you can always resample them. Okay, so just bear that in mind as well. So this is just a cheap way to have this connect and grow across multiple surfaces. The pattern's not fantastic at the moment, and we could even maybe with the endpoints, instead of saying 1 of every 2, say 1 of every 20th, just for something different. You could even go back up to the fuse, add more connections, and then you end up with something like this. These are just ideas for you to play with. But, it can be fun stuff. Turn off the smooth again. There's so many ways to get different looks. All right, so there's that. Let's just disable this merge here for now. Go back to the end. Go 1 of every 2. And going back over something I mentioned right at the start, how, we know that the curves grow along the edges of the topology, okay? So that's key in giving us the look that we're after. So just play around with different ways to alter the topology. For example, we could get rid of the remesh here. We could go VDB from polygons. Okay, and add some resolution. Then convert VDB. My tree's getting a bit messy here. Make that polygons, and you get somewhat of an even flow of polys here. But if we move all this down, you could put down something like a smooth or something like that. Add some iterations in, come to our find shortest path, and then all of a sudden, down to our null or our width, and grow this. And you probably don't want the smooth on for this one. Turn it off. We get cool patterns like this. So some of this stuff can look really interesting and look really different to what a regular growth algorithm would produce. Remember, one one of the main differences between, the point-based approach in a wrangle or whatever and the find shortest path is with find shortest path, we're always going to hit our target endpoints. With an algorithm, it can just start growing and just go wild, and you can't really ever predict what it's going to do. Well, you can somewhat, but not, 100%, where this is a targeted approach. And just a different look, something that we can, manipulate in a number of ways. That's it for another tutorial, guys. Thanks so much for watching. I hope you enjoyed it, and I'll see you real soon.